Tuesday, February 20th, 2018. We're going to take a look back to February 15th, last Thursday. Okay, that day it was down this way, 72 degrees and overcast. Nice day. Well, the sky didn't look so pretty, but we'll get there. And then following day, the 16th, we have rain and wind and temperatures in the low 50s. Okay, that would have been on Friday. Now here is Thursday evening. This is in Friendsville, Maryland, the Geoengineering River, and as you can see, we got a bit of flooding. Okay, that was the day it was 72 degrees. Just northwest of that, in Uniontown, Pennsylvania, we have a confirmed EF1 tornado. Okay, spring-like weather. Got that? Okay, we're going to go now to my photo gallery. We'll go down to that day, the 15th. And where are we at? Right about, yeah, right here. This was the day. This was before. Here's a meme I made. We got the stacks back here pumping up water vapor. It says, now I got this from an article called The Devil's Bargain. And in it they stated there's documented evidence that thunderstorms in China vary on a weekly cycle in tune with factory schedules. Okay, now when you get into the abstract and all that, it's talking about how different aerosol types can either dry out the atmosphere, saturated. But anyways, we'll continue. Here's the tail end of that storm. This is the 16th. See a couple microwave pulses. Here we got, this is the 17th. Okay, remember we went from 72 degrees to 50 degrees to 35 degrees and snow. Okay, this was unexpected. It was calling for possible rain showers in the afternoon, and well, we got snow instead. Here's early in the morning before the snow. You can see the trails from that the planes laid. Bit of frequency patterns here. Look at this off the coast. You can see this mess coming in. It dropped snow on us. And just look at that mess. Huh. Unbelievable. Here's the beginning of that snow. Here we can see the next rad, where you can follow these lines back, and that's where the next rad is. Leaves those patterns in the precipitation. You'll often find straight lines and angles. And there's the snow. Okay, that was Saturday. Now we move on to Sunday, which was the sky was wretched. It was warm. It got probably up to 50 degrees. Most of that snow melted, and as you can see, just a layer of haze over top of us all day with the planes. Alright, here we got a sundog. Now, I was told that this could be a possible indicator of how saturated the atmosphere is. And like this guy just trashed. I got a few photos up here. I believe this is photos from, well, uploaded them yesterday, but as you can see, this snowstorm, right? Now, there's one behind it. That was the last shitstorm. It goes up, and once it gets up, they start gouging high pressure in it, and it forces it into a cyclonic type system. Okay, we'll show that here. I believe I got it right here. Okay, wait till this starts over. Right there, comes off. They start gouging high pressure in it. Right, and it starts wrapping that up into basically a hurricane. And you can see that other one out in front of it, and then the one behind it. This has been kind of a repetitive cycle here of what's going on here. Right here, we'll take a look. This is off the west coast, and there's usually always, you got all this pollution. These are from ships here. These red lines, these are ship tracks. Or yeah. And then you'll have the planes, the traffic, and you'll have high pressure installed. And this is how they cause the drought here in California. It's constant pollution and high pressure. And this pollution creates a capping inversion layer, which prevents atmospheric lift, which is needed for precipitation. Now, if you want to follow the West Coast real good, I'd suggest one Pacific Redwood. He's kind of repetitive, but I think he's on his stuff there about what's going on with the drought. And here's another cyclonic type system just off the coast of Alaska there. You can see the big straight line and the square carved out of it. Now here's the sky was all hazed out. This is that day there down here, this mess. So we'll take a look at these stills here, and you can just see the complete aerial assault. Look at that. It's a little further south. I mean, just suffocated. It gives me a headache just looking at it. And here's that one system that brought snow, and this is right where they start gouging the high pressure in it. And you can see the straight line and the angles, and the frequency patterns, I guess you could call it mechanical type patterns, which shouldn't be in Mother Nature. That should be quite obvious. Now this is yesterday, Monday, and it's just, no more steering them clouds at all. You can see the frequency waves in that. Here's a building down the street from me. Like a low income housing. They got cell transmitters strapped to it. And I mean big boys. And then these signs right on there. This green one and this yellow one states right on there that the radiation coming from these antennas exceeds human exposure limit. But yet, in both of these buildings, the low-income housings downtown, they have them strapped to both of them. That's got cancer written all over it. Okay, here's more pollution. Then it started filling out more. And this is what the sky looked like last night before the sun went down. And then we'll get to today. Today, sun's poking up. We get this nice cotton candy purple, pink, and orange sunrise. You can see all day with the planes again. Today it got up to 81 degrees. Okay, we went from 72 tornadoes, flooding, the snow, back to like today was almost like a summer day. You can see the chem bombs, these long, wispy, feather-like trails they left today. It just spreads out into this, I might believe it was just water vapor or contrails if the trails didn't act so differently all the time. They do multiple things. There's the thermometer, 80 degrees. All this heat spraying you can see. Here's locally. So here you gotta look from above. Here's a better view. And you can just see these long wispy chem bombs is what I call them. Aerosol dispersals. 81 degrees. Here's a map I found. This is of all the NEXRAD type radars around the world. You have X band, S band, and C band. This is where they're all located. And I don't know if this will load right, but this anomaly on that mimic map from the other night, I mean, you can just see a shot fired and then it shoots over that way. Now this comes up this way often from down here on there's a little island, oddly it's called Rothschild Island, odd enough. But I seen a picture of it and they had it looked like 6 like dome radars, like the ones they put on the barges out in on the sea. The larger ones, I believe they are X band, but they look like they had about 6 of them set up there. So if that may be what's causing this, because this one comes up often from there. But this crap out here, right there, I'm not quite sure what that is from. But it's some type of interference. Something's caught. This is the microwave imagery. Something is causing interference. Now we'll move on. Here's from the other day. This would be the 16th. But this is caused by the radars. You can see the microwave patterns in it. This is called heterodyning. You can see the frequency waves go on in multiple directions. It's a mixing of frequencies, and you can kind of see it twist up there in the end. Oh. See that? Okay, now we're going to look at the most recent images. And today, they're just pumping it up in Texas for like the past day or so. I mean, then you can see all these chem bombs on the outer edge here probably help guiding the pollution from that. Like I said, it creates a inversion layer, so you ain't getting no lift there. And then we'll take a closer look at that just to see how they had cooking down here in Texas, just cooking. Here's the visible feed. I mean, that's cooking. And this is where most of our weather comes from, on the East Coast. You see all the chem bombs being laid there. But yeah, it's usually most of it starts down here in Texas, generated from down here, and it just flows up. Here's a look. I showed you my sky, the chem bombs. I mean, just look at that filth. Alright, here we're going to look at past few days on the NEXRAD images. See that nice big interference signal there? That's probably caused from the paved pause unit, another phased array system it's part of the space fence, causing this interference here. But then you see all these other ones blooming up, and you can see them pushing upwards. And this is a heterodyning roll. Okay. Now we'll hit the next, because this shows up a little better and it slows down on the latter half, and you can see this pulse a little more defined. Right there. Now I assume that all of these different radars and stuff work together in conjunction. Okay, here's yesterday up until about 3 o'clock today, and you can see the bloom up, the heterodyning pushing upwards there, right? And then here's the most recent, and they're blooming back up again. Now this is, you usually don't catch this in the winter time. I reckon that's why we probably having spring-like weather, because they're letting it happen, or they're making it happen. Now for the heterodyning, I see this. You see how this is bloomed up. Now we're going to go here. This is Weather War 101. Here's a good playlist I would suggest. Introduction to Geoengineering 101. There's a good bit on the next rad. Cooling towers. Yeah, that's mainly what he or she covers. Heterodyning is a radio signal processing technique invented in 1901 by Canadian inventor-engineer Reginald Fresnel. I may not have said that right, but in which new frequencies are created by combining or mixing two frequencies. Heterodyning is useful for frequency shifting signals into a new frequency range and is also involved in the processes of modulation and demodulation. Now we're going to get a audio visual of this, okay? Now I showed you what them next rads were doing in the southeast. Okay, now this would be a side view of that. If you can imagine looking at that from the side. Or imagine looking at this from the top down. Right? Okay? We got that? Now, like I said, that's side view. Now we'll go over here. Now just imagine looking down when these things bloom up. Okay? Shows up a little better there. And this is, you know, next rads are what's causing these patterns. Well, yeah, it's my belief that these are what's causing the frequency patterns that you see in the sky. Now here's a good graphic, and then I'll probably just end here on this. I like this graphic Jim Lee created. It's got 10 technologies to own the weather today. Okay, 1, you have ionospheric heaters. This is like a harp-like device. The big boys here. 2, sounding rockets. Now we have a ATK orbital locally, just up the river, a few miles, and they actually build these there. And then these go up into the ionosphere, release chemicals, aluminum, barium, strontium, cadmium, you name it. And they got to spray that so HARP it's got a medium to interact with. 3, we got satellite technologies. 4, lasers, which they can produce plasma too. 5, cloud seeding. Now this can be done via aircraft, or they got ground seeding generators, on the ground, and they have these lined up and down the Rockies, and they run from October to spring, so they're running for like almost 6 months, and they're spraying silver iodide into the sky. Okay, 6, cloud ionizers. Oh, actually, I got that mixed up. 5 over here. This is the cloud seeding device. 6 is the ionizer. Okay, like Let's say you got like an ionic breeze in your house, like that's essentially the same way this works. It ionizes the air, moisture sticks to the pollution, and then it falls to the ground as rain. 7. Stratospheric aerosol injections. Okay, this looks like some kind of tower spraying chemicals, but this can also be done via aircraft and balloon. 8. Ship tracks. I showed this what the ship tracks look like off the coast of California. 9. Contrail-induced cirrus, now aka chemtrails. That would be your airplanes. And then 10. Water vapor pollution. This would be your factories and power plants pumping up water vapor into the sky. So, with all that said, I think I covered a good bit tonight. Hopefully, you all got something out of it. We'll check back in at a later date.